Hello everyone! Today we are starting with the WLAN networking model. As the demand for mobile office increases, the application of WLAN is becoming more widespread. So, how to build a WLAN that meets our business needs is a significant issue for our enterprises. Also, different enterprises have different requirements for WLAN. If we are to build a new network, we need to consider whether its network model is Layer 2 networking or Layer 3 networking, whether it is direct connection or bypass networking. At the same time, we also need to consider what its forwarding mode is. If we are to add a WLAN to an existing network, then the considerations are different. So today we mainly need to understand how to design a WLAN network. This involves choosing an appropriate networking method. This chapter will introduce WLAN network design and typical networking solutions. After completing this course, you will be able to summarize the basic concepts of WLAN, describe WLAN networking methods, differentiate WLAN forwarding models, and evaluate Huawei's typical WLAN networking solutions. Let's start with the basic concepts of WLAN. Firstly, BSS and BSA. Usually, when using WLAN networks, we connect to the wireless signal using a computer or smartphone. That wireless signal is actually the SSID here. But to connect to an SSID, you must first have an AP. At this time, the area formed by our phones and computers with the AP is our basic service set. Note that the BSS includes a fixed AP, which is one, not multiple, and includes multiple terminals, where a multiple can mean one or more. At this time, we use a phone or computer to connect to the AP. The premise is that the terminal must be within the coverage area of the BSA or the AP. The area covered by the AP is called a BSA, and the terminals must be within the BSA to communicate with the AP. This is what we refer to as BSS and BSA. Here we also introduced an SSID. Let's continue to look further. If our phone or computer wants to connect to a wireless network, firstly, we need to know the name of the wireless network. So this SSID is essentially the name of the wireless network, or it can be seen as an identity marker for the wireless network. At this point, there might be multiple APs. For example, one is AP1, another is AP2. These two APs might emit the same signal, both named guest, if they are both called guest. We need to understand which AP my terminal is actually connecting to. At that point, each AP needs an identity marker, which is the BSSID, meaning that the SSID is an identity marker for the wireless network, and BSSID is an identity marker for an AP. This identity marker is the identity of the basic service set. So, at this point, can two APs be identified through a basic service set identity? Which AP are we connecting to? BSSID is usually our MAC address. That's the difference between SSID and BSSID. SSID is the name of the wireless network, while BSSID is an identity marker for the AP, which is our AP's MAC address. It uniquely identifies an AP. However, usually an AP does not only release one signal, an AP can release a guest and also release an employee. This is also very widely used in our lives. For example, a home router typically emits two signals, a 2.4G signal and a 5G signal, but there is actually only one wireless router. We just mentioned that a BSS is made up of one AP and multiple terminals. In businesses, when we turn on our phones or computers to search for a wireless signal, we see a list of signals, which may be emitted by one or more APs. Let's assume these are signals from one AP. Each signal can form a BSS with the surrounding terminals, indicating that this AP has emitted multiple BSS. Thus, a physical AP can be virtually divided into multiple virtual APs, which is referred to as VAP. Each virtual AP corresponds to a basic service set, and multiple virtual APs correspond to multiple basic service sets. By setting different SSIDs for these BSSs, users can see multiple WLANs coexisting, also known as multi-SSID. So, how large is the coverage area of an AP? We generally assume its effective radius is between 10 to 15 meters, but we've noticed in our work that our movement often greatly exceeds this distance, yet our network connection remains uninterrupted. For instance, sometimes when we're in a mall, watching videos on our phones, we continue watching as we walk, and notice that the video plays seamlessly. Why is that? It's actually because different BSSs are connected. Here, the two BSSs were originally independent, but when we are in BSS 1, the phone connects to AP1, and as we move, it will connect to AP2. These two APs share the same SSID. What connects these two independent BSSs? In fact, we need to connect different APs to a larger network, which is the uplink network of the AP, known as the distributed system, DS. This is the concept of DS. Additionally, we mentioned that these two originally independent BSSs are linked, and when the terminal switches from AP1 to AP2, the switch is essentially seamless, unnoticeable to us. These two BSSs form what is called an extended service set, ESS, transforming the two basic service sets into one extended service set. There are several requirements for forming an ESS. First, the APs of the two independent BSSs must be connected to the same DS. Second, the SSIDs of the two basic service sets must be identical. Third, the two BSSs must have overlapping coverage areas, primarily to provide seamless roaming service. As we move from the coverage area of AP1 to that of AP2, the network remains essentially uninterrupted. These are the three necessary conditions to form an ESS. Finally, let's summarize these basic concepts, focusing on these 6 points. First, let's compare BSS and ESS. One is a basic service set, comprising a single AP and several wireless terminals, forming a service set, while the extended service set evolves from the BSS, consisting of multiple BSSs with the same SSID. It mainly solves the problem of limited BSS coverage. Then, SSID and SID are essentially the same. SSID is an identifier for a BSS, while SID is an identifier for an ESS. SSID distinguishes different wireless networks, acting as a name for the wireless network, whereas SID identifies one or a group of wireless networks, all under the same SSID. Lastly, let's look at VAP and BSSID, where VAP is a virtual AP derived from a physical AP. Huawei wireless AP devices can virtualize up to 16 APs, meaning one Huawei AP can emit 16 different SSIDs, where each virtual AP exists independently. If a terminal wants to connect to virtual AP1 or AP2, it needs to identify which virtual AP it is connecting to, which can be identified through BSSID, which is also the MAC address of the virtual AP. These are some basic concepts of WLAN. In the next lesson, I will explain WLAN networking architecture. Thank you, and see you in the next class.